Visual Studio is an integrated development environment, or IDE, that allows programmers to write, compile, and link their programs within one unified interface. It is organized in a hierarchical structure. At the top level are solutions. Solutions consist of a set of related projects. Each project results in an executable program. Within the project are source files, the various individual modules of code that are compiled together to create an executable. A solution must have at least one source file. High-level programming languages like C and C++ are independent of the hardware and have to be translated to machine code in order to be executed. This process involves compiling and linking. Visual Studio takes care of this process for us, as we will see when we build our executable program. Let's create a new solution. Go to File, New, Project. By default, this process will automatically create a new solution as well. Go to Visual C++, then select Win32. The project we want to create is Win32 Console Application. This template is for a C or C++ program for Windows, and no additional libraries beyond the ones enabling standard text operations will be added. You can give the project a name at the bottom of the dialog. You can also name the solution and choose a location for the project. Checking Create Directory for Solution will put all the project files in their own folder, separate from the solution file. Click OK, then Next. Select Empty Project in the Application Settings dialog, then click Finish. The project is now set up. All we need to do is create a source file. In the Solution Explorer, right-click either the Source Files folder or the project itself and go Add New Item. Select C++ Source and give it a name. It'll appear in the Solution Explorer. With only a humble main function in our source file, we can build the solution. This creates output files in two user-selectable settings, each in a different folder, Debug and Release. Debug mode has extra information to allow debugging. This results in larger file sizes and slower programs. Release mode removes this information and makes the program ready to be released. You can execute the program by using the green play button in the toolbar. This is the local Windows debugger. Alternatively, you can go to the Debug menu and use one of the two options. Start debugging, which is the same as the play button, or start without debugging. This option will hold the window on screen after the program ends, and is good for programs that end quickly so you can see the results. You can also start debugging by pressing F5. In order to use the sample code in these tutorials, you have two options. You can create a new source file in your project as we've discussed previously, then copy and paste the code into it. Or you can put the sample source file in the project folder and add it to your project. You can get to the project location by right-clicking on it in the Solution Explorer and choosing Open Folder in File Explorer. Once it's in your project folder, you can add the file by right-clicking on your project in the Solution Explorer and selecting Add Existing Item. Then you just need to select it. Now let's look at the basic components of a C program. First, there are the language elements. Just like any spoken language, C consists of a series of fundamental building blocks. Each part of the code in a C program may belong to one of these elements. Keywords are predefined text that the compiler understands, things like void, int, float, if, and for. Operators perform standard operations on data. The obvious examples are mathematical operators such as add, subtract, multiply, divide, or modulo, which we'll talk more about later. But there are operators for other data types as well, not just numeric ones. Punctuators are symbols that organize the code.
They serve exactly the same function as punctuation in a written language. Semicolons, for example, mark the end of a statement of code. Constants are concrete, defined values. A constant could be a number such as 12 or 34, a character like S or D, or even a text string like the word hello. Identifiers are names given by the programmers to define data and code. Basically, anytime you're making up a name to use in your code, you're creating an identifier. Variables, functions, that sort of thing. Comments are sections of text in your code that are to be ignored by the compiler and therefore will have no effect on your program. Comments can be used to explain parts of your code to other people who aren't familiar with it, or to provide additional information. Visual Studio has a range of customization options that make reading your code a fair bit easier. If you go to Tools, Options, under Environment, look for Fonts and Colors. Here you will find a list of display items, the appearance of which you can change. For these tutorials, we will have operators show up in blue and numbers show up in red instead of black. This should make reading and interpreting the code easier. Feel free to make any other adjustments you like. Changing the color theme under Environment to dark may help to reduce eye strain when coding for extended periods of time. These changes have no effect on the source code. Also, if you're making these changes on a school computer, they will be lost once you log out. You can save the changes to a file, though. If you heavily customize your environment, this can be very useful. Just go to Tools, Import and Export Settings. Export will create an environment customization file you can then import whenever you're using a different computer. Next, let's talk about data. Every program processes some information. In C, data is maintained in constants and variables. The values of constants are always the same, whereas the value of variables can be changed. Variables are essentially a location in the computer's memory with a name, a value, and in C, a data type. To declare a new variable, state its type, then the identifier you wish to give it. All statements in C end with a semicolon. C supports several standard data types such as bool, char, short, int, float, and double. Each of these data types occupy different amounts of memory. The first, bool, can contain a true or false value. Char contains a single character. The latter four can contain different ranges of numbers. Int stands for integer and is used for whole numbers. The other three, float, double, and short, can be used for decimal numbers, the only difference between them being the lengths and use of decimal points. We can assign an initial value to our variable in the same statement that created it. Assigning a value to a newly created variable is called initialization. When dealing with numbers, it is sometimes necessary to specify what data type your constants are using. Whole numbers are, by default, integers. Numbers with a decimal are considered to be doubles. You can force constants to be floats by adding f to the end of a number. Remember, for any information used in the program, create a proper variable. This is the first golden rule of programming. Now let's get to the meat, the actual code. The code in C programs can easily be structured within functions. A function is essentially a mini program that can be executed from somewhere else in your code. You can define a function by stating its data type and name, followed by a pair of parentheses, and then the body. A function's data type refers to what type of value can be returned. If you want to write a function that returns a whole number, for instance, then the function will need to be an int. If you don't need your function to return a value, then you can set its data type to void. It should be noted that any line of code that starts with a data type is creating something new, whether it be a variable or a function. When you declare a variable in your code, it will be in one of two places. If you declare it within a function, it is called a local variable. This means that only that specific function will know about it. Other functions you create will not be able to access it. If you declare the variable outside of a function, then it is called a global variable. Global variables can be accessed by any part of the code. This leads us to the second golden rule of programming. Define variables and functions before using them. The reason for this is simple. Computers are very dumb. They need to know about any new functions or variables before they can use them. It's like a recipe. You can't follow the instructions before you know what ingredients you need. If the compiler comes across a variable or function it hasn't heard of yet, it'll complain about it. For this reason, and for readability, it is best to keep all your global variables together at the top of your code, followed by any functions you've created. For the time being, include your main function at the end of your program. A common practice, though not a required one, is to preface your global variable names with G underscore.
Hash include inserts another file into the code. Header files, or .h files, usually list code and data not created in this file. Libraries such as stdio.h are one such example. stdio stands for Standard Input and Output. If the name of a header file is inside double quotes, then the system looks for it in the same folder as the current CPP file first. If it's not found, then it looks for it in the standard system folder for C include files with the Visual Studio installation files. This can be used for standard header files or the one we are creating for our project. If the name of the header file is inside a pair of angled brackets, the current folder is ignored. This is only used for standard header files. All C programs have a function called main that is executed when the program starts. Functions and variables are defined by specifying a type and a name. Functions are followed by parentheses for parameters and curly braces for the body. Variables consist of a type and a name followed by an optional value. Writing just the name of the function without its type or body will call or execute that function. For example, printf is defined in stdio.h and used in our sample code. It prints text to the console window. The text to be printed is a parameter of the function. In C, a text string is denoted using double quotes. To print the value of an int, for example, we write %d in the string and include the variable name as a second parameter. The value of the variable will be substituted in where %d is located in the string. To substitute in a variable of a different type, we need to use a different character following the % sign. For example, %f is used for floats. To receive a value from the user through the keyboard, we can use the Scanf function. In this case, the parameter we use should just be the % type followed by the variable. The variable needs to be preceded by an ampersand. We'll talk more about why this is later. In newer versions of Visual Studio, we can use scanf_s, which is the safe version of scanf. It just limits the input data to the amount allowed by its type to prevent security threats. If you want to learn more about it, look up buffer overflow. If we look at some code for calculating a restaurant bill based on the meal price, tax, and tip, we see that there's an important order of operations. It follows the same principles you may have learned in high school. Operations enclosed in parentheses happen first, followed by multiplication and division, followed by addition and subtraction. Each group is evaluated from left to right. C programs can use a variety of pre-built code for common tasks. These are called libraries. To identify which library the program is using, we include the header file for it, such as stdio.h. Another library for input and output is called IOStream. From this library, we can use cin and cout to read from the keyboard and write to the screen. Programmers can choose which method they prefer. cin and cout use a different syntax from most C functions, but they're also usually more convenient to use. And that's it for a basic introduction to the C language. Soon, we'll cover more advanced topics.